Welcome to Orangedale, Cape Breton. I'm visiting my son JT and his cousin Marcel. They're out ice fishing right now. They're gracious enough to lend me their whiteboard at their cabin while they are out there ice fishing. So I thought I'd take a look at integration by parts, order of operations today. In arithmetic, we have order of operations, BEDMAS, brackets, exponents, division, multiplication, addition, and subtraction. So why not have it for integration by parts? And this is not my idea. I came across this somewhere on the internet. Let U equal lipid. That's the order of priority. So if your integral expression involves logs, that's your number one priority. That takes first precedence. Number two, if there's no logs and there's an inverse trig, that's next precedence. I've actually never seen those two together. I'm sure they're out there, but be an interesting one to take a look at. Add to your comments here if you know of a good one. Third is polynomials. P for polynomials, E for exponential functions, and T for regular trig functions. Of course, this is our integration by parts formula. Integral u dv equals uv minus the integral of v du, which is really the undoing of the product rule. So we don't have time in today's video to look at that, but you can look that up on another site. So I have 4 problems here, 1, 2, 3, and 4, and we're going to do each of those by using this rubric. So for starters, the first one we're looking at is we have a polynomial and we have a logarithm, natural log. Well, polynomials are way down on the priority list, so logs are number 1, so we let u equal the natural log of x. Part of the reason for letting u equal the natural log of x is because if we let dv equal the natural log of x, that's a tough one to integrate. So that means dv is what's left, 6x squared dx. Here, of course, we find du. du equals 1 over x dx. This side we're differentiating, on this side we're integrating. And the integral of this is 6x cubed over 3, which is 2x cubed. Integration by parts formula, of course, you can see it's uv minus the integral of the product of v du. So that becomes equal to 2x cubed ln x minus the integral of 1 over x 2x cubed dx. Simplify. And we have an easy integral here. And to complete the integral, plus c. Bam. So if there's a natural log, or log of any base really for that matter, you let u equal that and dx or du equal or dv equal whatever's left. There's the first one done. Look for my eraser. Okay. Number 2, u equals tan inverse, or also called arctan of x. No logarithms. It is an inverse trig. So we're going to let u equal the tan inverse of x. Therefore, dv equals what's left. Well, the only thing left is dx. You want to call it 1 dx. If you find that helps, you're more than welcome to. Again, letting dv equal tan inverse of x would be kind of difficult because what's the integral of it? I don't know what it is. So over here we differentiate 1 over 1 plus x squared dx. Here we integrate, and of course it's the formula calls for uv minus the integral of this product. And we have a somewhat easier integral here to deal with. I'll skip the part where you have to do this by substitution. We'll just do it directly here. We can see that it needs the derivative of 2x here if I let u equal this expression. So the 2 is missing, so I pop a 2 here, pop a 1/2 up front to balance it. We end up with x tan inverse of x minus 1/2 the integral of 1 over u du, where we let u equal 1 plus x squared and du equals 2x dx. So the integral of that, of course, is a natural log. Typically we put absolute value here, but since 1 plus x squared is always positive, we don't need it here. It would be redundant. So minus 1/2 the log of 1 plus x squared plus c. Bam, second one done. Looking at the third one, we see we have an exponential and a polynomial. Well, polynomial comes first, precedence, so u equals x, dv equals e to the x. If you did it the other way, you just make a more complicated integral and you find out you should bail out. So here du equals dx, or 1 dx, v equals e to the x, one of the easiest integrals you're going to get. So therefore it's equal to the product of uv minus the product of the integral of this product. So that becomes x e to the x minus this product, which is just e to the x dx, which becomes x e to the x minus e to the x plus c. Bam. So third iteration, or third order of precedence polynomials is next. The last one combines the last two, exponential and trig, and notice here I've got an equal sign. It's because they are equal precedence. It doesn't really matter which one you do for u. The only consideration is if you let u equal one of them, you let u equal subsequently in the second iteration the same one, otherwise it'll just undo what you just did. So here I'm choosing u to be e to the x, dv equals cosine of x, so du equals e to the x dx. We need a dx here. And so v is equal to the integral of that sine of x. So the product of those two, it's going to equal e to the x sine x minus the integral of e to the x sine x dx. Well, we've got to do it again. There's the first iteration, second iteration, u equals e to the x, dv equals sine of x dx, du equals e to the x dx, v equals negative cosine of x dx, or no dx, I'm integrating there. So it's going to be the product of those two, minus that, so we have e to the x sine of x minus, and of course this minus is of the whole integral, so I need to do this first, which is negative e to the x cosine of x, subtract, because that's what the formula calls for, subtract the integral of this product, which is e to the x cosine of x, negative. This makes it positive, but this will make it negative. This makes this positive. So positive, now negative. And at this point, you might note that I'm going to erase all this top stuff here, make room. We can see that this expression here is exactly the same as what we started with. So if I put a 1 in front of this one, I put a 1 in front of this one, and we're going to add the integral of e to the x cosine of x dx to both sides. Of course, these two buddies cancel out. We end up with 2 of these. Equals this. And the final step is to get the original integral, divide everything by 2. Or 1/2 times this. Plus c. So order of operations can be used in integration by parts. Makes your job a little easier. So it's called lipid. Logs, inverse, trig, polynomials, exponential, and trigonometry. Keep your mask on, keep a safe distance, keep safe. Thank you.